What if a piece of another star system has been drifting through the darkness of space for 10 billion years, and it just happened to fly past our sun while we were watching? Not a rumor, not a theory. A confirmed visitor, caught by the most powerful telescopes humanity has ever built. And what they found hidden inside it might change how you think about where we come from and whether we are alone. If you want the real story, backed by real data, before the internet turns it into something it is not, hit subscribe right now. Because this is one of those rare moments where the truth is stranger than anything anyone could make up. Let us start with the basics, in plain simple words. Our solar system has one sun, 8 planets, a bunch of moons, and countless smaller objects like asteroids and comets. All of them are bound by the sun's gravity, locked into paths that repeat over and over. But every once in a while, something shows up that does not belong here at all. Something that came from outside our solar system entirely, from somewhere out in the wider galaxy, and is only passing through our neighborhood once before it leaves forever, never to return. These rare visitors are called interstellar objects, and in all of recorded human history, we have only confirmed 3 of them. 3. Out of every object ever cataloged by every telescope that has ever existed, only 3 are known to have come from beyond our solar system. The first showed up in 2017, small and oddly shaped, tumbling through space in a way that made people talk about it for years. The second arrived in 2019 and behaved more like a normal comet with a visible tail. Both came and went quickly, fading before telescopes could study them properly. Let us slow down and talk about those first 2 visitors, because understanding them makes it easier to appreciate why the third one was such a big deal. The very first confirmed interstellar object was unlike anything astronomers had ever cataloged before. It moved through our solar system on a path that made it obvious it was not bound to the sun, with a strange, elongated shape that made headlines around the world. What made it so puzzling was how quiet it was. It showed almost no visible activity, no obvious gas or dust streaming off it the way a normal comet would. That made it incredibly difficult to study. By the time telescopes understood what they were looking at, it was already too far away and too faint to learn much more from. It left more questions than answers. The second interstellar object arrived about 2 years later, 2019. This one behaved very differently. It showed a clear, glowing coma and a visible tail, acting much more like the comets astronomers already knew from our own solar system. Because it was more active and easier to observe, scientists gathered a much richer set of data on its chemistry and structure. Even so, it too was already on its way out before much more could be learned. Both of those earlier encounters left scientists hungry for a third chance. One where a bigger, brighter, more active object might show up with enough warning time for the world's best instruments, especially newer tools that did not exist back in 2017, to get a proper detailed look. That is exactly what happened next. On July 1st, 2025, telescopes at a survey station in Rio Hurtado, Chile, spotted something moving fast across the sky. The station is part of a network called the Asteroid Terrestrial Impact Last Alert System, telescopes built to scan the sky every night for objects that could be dangerous to Earth. That night, the system flagged a faint to fast-moving point of light. Astronomers checked its path, and within days they had their answer. This object was moving far too fast to be trapped by the sun's gravity. It was not going to loop back around. It was going to pass through and keep going out into deep space again, never to return. This was the third confirmed interstellar object ever recorded. It was eventually named 3I Atlas. The number 3 marks it as the third of its kind, and Atlas honors the telescope system that first caught sight of it. Right away, something about this new visitor stood out. Its path around the sun was more extreme, more sharply bent than either of the 2 interstellar objects that came before it. In simple terms, the shape of an object's path tells you how strongly it is attached to the sun's gravity. A path that curves gently and loops back belongs to our solar system. A path that comes in fast, bends only slightly, and shoots straight back out is only passing through. 3I Atlas had the most extreme, most sharply hyperbolic path of any interstellar object ever measured. It was moving through our solar system at a staggering speed, well over 200,000 kilometers per hour when it was first discovered, and it only got faster as it fell closer toward the sun. Here is where the story gets genuinely shocking. Based on how fast this object moves relative to the average motion of stars in our part of the galaxy, scientists estimated how long it has been drifting through space since it was flung out of whatever star system it originally formed in. Their estimate placed its age somewhere between 3 billion and 11 billion years old. And more recent analysis pushes that even higher, suggesting it may have formed 10 to 12 billion years ago, during what astronomers call cosmic noon, when the universe was churning out stars at an incredible rate. For comparison, our own sun and solar system are about 4.5 billion years old. That means it is entirely possible that this comet is more than twice as old as our sun. It may have formed around a star that existed and died long before our own star ever ignited. And it has been quietly drifting alone through the galaxy for that entire time, completely untouched, until it happened to cross paths with our solar system. If that alone does not stop you for a second, I do not know what will. A frozen piece of another solar system, possibly older than our own, just drifted close enough for our telescopes to study it. And this is where things really got interesting, because unlike the first interstellar visitor, which looked mostly inactive and rocky, 3I Atlas turned out to be a genuinely active comet. As it neared the sun, frozen material on its surface started turning directly into gas, streaming away and forming a glowing cloud around it called a coma, along with a faint tail. This activity was a huge deal for scientists because an active object releases its internal chemistry into space, where telescopes can actually detect and analyze it. A quiet, inactive rock does not give up its secrets easily. An active, outgassing comet practically hands them over. Now, if you're finding this genuinely interesting, here's the thing. We are about to get into exactly what the James Webb Space Telescope found when it turned its instruments toward this ancient visitor. And it is stranger than most people expect. So make sure you're following this channel right now, because the next few minutes are going to change the way you think about comets and about our place in the galaxy. Drop a follow, and you will be here when the rest of the data comes out. The James Webb Space Telescope, often just called JWST or Webb, is the most powerful space telescope humanity has ever built. It does not see light the way our eyes do. Instead, it is tuned to infrared light, longer wavelengths than what we can see, letting it pick up heat signatures and chemical fingerprints invisible to regular telescopes. This makes it perfect for studying the exact chemical makeup of distant, faint objects like comets. Webb was not originally built with fast-moving small solar system objects in mind. Tracking something moving as quickly as 3I or Atlas across the sky pushed its tracking systems in ways it was not really designed for. Despite that challenge, engineers and astronomers managed to lock Webb onto the comet in August of 2025, capturing its first detailed spectrum, essentially a chemical fingerprint made of light. Then, after the comet swung around the sun and began heading back out of the solar system, Webb observed it again in mid-December of 2025. This time, using a different instrument tuned specifically to mid-infrared wavelengths, capturing the most detailed chemical readout ever taken of an interstellar object. What came back from those observations surprised a lot of scientists. The comet's chemistry was unusual compared to typical comets that formed here in our own solar system. For one, it showed an unusually high amount of carbon dioxide compared to water vapor, a ratio that stood out from the norm. Comets from our own solar system, studied for decades, tend to follow expected patterns in how much water versus carbon dioxide they release. This visitor from another star system broke that pattern. In fact, its coma turned out to be dominated by carbon dioxide, with a ratio to water among the highest ever observed in any comet. That hints that whatever environment it formed in was chemically different from the one that built the comets native to our own solar neighborhood. And here is where the story takes an even deeper twist. Webb's instruments also detected water vapor, carbon monoxide, and a molecule called OCS, along with actual water ice and dust streaming off the comet. But the most striking thing was the heavy water. Scientists found that 3I Atlas is unusually rich in deuterium, a heavier form of hydrogen, sometimes called heavy hydrogen. The level of deuterium in this comet's water is about 30 times higher than what we see in comets from our own solar system. That is a massive clue. Deuterium is a kind of chemical fossil. It tells scientists about the temperature and the environment where an object first formed. A comet that formed in a very cold place, very early in the galaxy's history, would keep more heavy water locked in its ice. The fact that 3I Atlas is swimming in deuterium suggests it spent its formative years deeply frozen in a cold, dense cloud very early in the history of the universe. There's another clue hiding in the data too. Webb found only traces of a heavier form of carbon called carbon-13 compared to the lighter carbon-12. That also points to a very old origin. Here is why. Over time, as generations of stars are born and die, they enrich the galaxy with carbon-13. Our own solar system, formed only 4.5 billion years ago, has higher levels of it. The fact that 3I Atlas has so little carbon-13 means it formed before the galaxy had been enriched by many generations of stars. In other words, this comet is not just old, it is a relic from a time when the galaxy was still young. Think about that for a moment. When this object formed, the sun did not exist. Earth did not exist. The material that would one day become your body and your world was still scattered across the galaxy. And this comet was already there, taking shape around a star that has probably been dead for billions of years. Now let us talk about size, because it matters more than you might think. Measuring a comet's solid core, its nucleus, is trickier than it sounds. From a telescope's point of view, the tiny solid core is almost always drowned out by the much brighter cloud of gas and dust surrounding it. Astronomers have to use careful modeling, combining brightness measurements at different wavelengths with knowledge of how reflective different materials tend to be, to separate the faint signal of the rocky and icy core from the glow around it. NASA's Hubble Space Telescope observed 3I Atlas shortly after its discovery and again after it passed the Sun. Based on those observations, scientists estimated its nucleus is somewhere between about 320 meters and 5.6 kilometers across. That makes it noticeably larger than either of the two interstellar objects discovered before it. And that larger size is part of the reason 3I Atlas became so much brighter and easier to study than its predecessors ever were. A bigger nucleus means more surface area to heat up and release gas, which means a brighter, richer coma for telescopes, and a stronger, clearer chemical signal for instruments like Webb to lock onto. Webb was not the only instrument studying this comet. A space telescope called SphereX, designed to survey the entire sky in infrared light, took its own look in December of 2025. And what it found was remarkable. The comet was erupting into space, significantly brighter than it had been before its closest approach to the Sun. SphereX detected increased activity after the comet's closest pass by the Sun, along with dust made of tougher, more heat-resistant material mixed into the coma, adding more detail to the comet's chemical story. Ground-based radio telescopes using a technique called ALMA observations also chipped in, detecting other molecules escaping from the comet, adding yet more pieces to the puzzle of exactly what this ancient visitor is made of. If you are still with me at this point, you clearly appreciate real science over hype. So here's what I'm asking. Go ahead and hit that follow button now, because there is one more part of this story that a lot of people online have been getting completely wrong. And I want to set the record straight with you, because 3I Atlas was moving on such an extreme path, and because it turned out to be surprisingly large and old, some corners of the internet ran wild, throwing around theories that it might not be a natural object at all. When something unusual shows up from outside our solar system, it is a completely normal human reaction to wonder what else it could be. Scientists take that curiosity seriously, and rather than dismissing it, they actually went and checked. Researchers used radio telescope arrays designed to search for technosignatures, any kind of artificial radio signal that might suggest an object was built rather than formed naturally. They pointed these instruments directly at 3I Atlas during its journey through our solar system. And they listened carefully across a wide range of radio frequencies. The result of that search was clear. No artificial signals were detected. Every single piece of data collected across every instrument, from Webb's chemical fingerprint to Hubble's imaging to the radio searches, points to exactly what an ancient natural comet should look like. Its behavior matches known cometary physics. Its chemistry, while unusual, fits within the range of what scientists expect from an icy body that formed around a different star. Its overall structure, its coma, its gas emissions, its dust, all of it lines up with a natural interstellar comet, not anything constructed or artificial. I bring this up not to dismiss curiosity, because honestly, the real verified science here is already wild enough on its own. A confirmed visitor from another solar system, possibly billions of years old, carrying chemical fingerprints frozen since before our own sun existed, studied directly by our most advanced space telescopes. That is already one of the most remarkable natural discoveries of the decade. It does not need embellishment. The truth here is stranger and more grounded than the rumors. So, what does all of this actually mean for us going forward? Why should it matter to someone who is not an astronomer? For one, every interstellar object we get to study up close gives scientists a genuine sample of material that formed somewhere else entirely, around a star system we will likely never visit. Instead of only theorizing about other star systems from distant light readings, an interstellar object lets scientists directly measure the raw ingredients that built planets and comets somewhere else in the galaxy. That is an extraordinarily rare opportunity. We have only had 3 chances like this in all of recorded history, and 3I Atlas gave scientists by far the most detailed data set of the 3, thanks to its size, its activity level, and the advanced instrumentation available compared to 2017. There is also a bigger scientific picture forming here. Each interstellar object we detect adds to our understanding of just how common these wanderers are throughout the galaxy. For a long time, scientists debated whether interstellar visitors like this were incredibly rare, one-off events, or whether space is actually full of them, quietly drifting past us undetected, simply because we did not have the tools or the timing to catch them. The fact that we have confirmed 3 of them within less than a decade, with detection technology still improving, suggests these visitors might be far more common than anyone guessed. As newer, more powerful sky survey telescopes come online, scientists expect the detection rate to rise significantly. In other words, 3I Atlas may not be a rare once-in-a-lifetime event. It might just be the third confirmed sighting in what could become a regular stream of ancient visitors passing through our neighborhood, most of which we simply have not had the tools to catch until now. That thought alone should change how you look up at the night sky. Somewhere out there, right now, more pieces of other solar systems are likely drifting through our own, ancient, frozen, and completely unnoticed, waiting for the next telescope powerful enough and lucky enough to catch sight of them before they slip back out into the dark. There's also a very practical reason astronomers are so eager to build better detection systems. A brand new ground-based survey telescope, built to scan the entire visible sky every few nights, recently began full operations. Many scientists expect it to dramatically speed up how quickly future interstellar objects get identified. More warning time means more chances to line up telescopes like Webb and Hubble in advance, the way astronomers did with 3i Atlas, instead of racing against the clock as teams did with the first interstellar visitor back in 2017. Every improvement in detection technology translates into richer science the next time one of these wanderers passes through. It is also worth remembering how much combined effort across countries and institutions went into understanding this one comet. The initial detection came from a ground-based survey network. Confirmation and orbit calculations involved observatories across multiple continents comparing notes within days. Space telescopes operated by different national agencies then took turns studying it from orbit, each contributing a different piece of the chemical puzzle. Radio arrays added still more detail from an entirely different part of the light spectrum. This is one of the more impressive examples of global scientific cooperation, happening quietly in the background, teams around the world sharing data and schedules, all working toward one goal: understanding this ancient visitor as completely as possible. Let us take a moment to sit with the timeline of everything this comet has been through, because it helps put the scale of this discovery into perspective. This object formed billions of years ago around a star that may not even exist anymore in a completely different region of the galaxy. At some point, gravitational interactions with other objects or a close encounter with a passing star flung it out of that system entirely, sending it drifting alone through interstellar space, with no star to orbit, no light to warm it, just endless cold and silence. For possibly billions of years it drifted like that, tumbling through the space between stars untouched, carrying its original chemistry locked away and frozen. Then, purely by chance, its long silent journey brought it close enough to our sun that our gravity could finally bend its path, and our telescopes could finally catch sight of it. It swept past the sun, warmed up just enough to release some of that ancient frozen material into space, giving our instruments a brief window to study it. And then it continued on its way, heading back out into the depths of the galaxy, likely never to return, possibly never to be seen again. Think about that against the full timeline of human history. Telescopes have only existed for around 400 years. Space telescopes capable of reading a comet's precise chemical fingerprint have existed for only a few decades. Out of the billions of years this object spent drifting through the galaxy, it happened to pass close to our sun during the exact narrow window of human history, when we had both the knowledge to recognize it as interstellar and the technology to study it in real time. A few hundred years earlier, it would have been just an unexplained blurry point of light. We happened to be alive, with the right telescopes pointed at the right patch of sky at the one brief moment this ancient traveler passed close enough to notice. That is an extraordinary stroke of cosmic timing. And now, here is the final layer of this story, the one that connects it to something deeply personal. Scientists are continuing to analyze all the data collected from 3i Atlas. And more detailed findings are expected to keep coming out as researchers dig deeper into everything Webb, Hubble, and the other instruments captured. Findings from this comet were formally published in a leading scientific journal, confirming its ancient, cold origins and cementing its place as the most thoroughly studied interstellar object we have ever encountered. Every new detail adds another piece to a much bigger puzzle about how solar systems form, how common these wanderers are, and what other star systems might actually be made of. But here's the part that should really make you stop. The scientists studying this comet are not just trying to figure out what 3i Atlas is made of. They are asking a much bigger question. A question about life itself. You see, the ingredients this comet carries, water, carbon dioxide, carbon monoxide, organic molecules, are the same kind that, here on Earth, somehow combine to produce life. The deep question is whether those ingredients are common across the galaxy or whether our little blue world is a cosmic accident. As one of the researchers put it, so far, we know of only one place in the vast cosmos where chemical ingredients led to life. Our solar system, our Earth, and analysis of these interstellar objects is a major step towards learning how common or how uncommon the conditions for the evolution of life really are in the universe. That is the real reason this ancient comet matters. It is not just a curiosity, it is a messenger, a frozen time capsule carrying the raw chemistry of another world, another time, another place in the galaxy, delivered to our doorstep by pure cosmic chance. And for a few brief months, our telescopes managed to read its secrets before it slipped away into the dark forever. So here is what I want you to take away from this story. The next time you look up at the night sky, remember that it is not empty. It is full of travelers. Ancient pieces of other worlds, drifting silently between the stars, carrying the chemistry of life, waiting for a telescope lucky enough to catch them. And the next time one of them arrives, we will be ready. Because of what we learned from 3i Atlas. If this story gave you a new appreciation for what real, verified space science can uncover, then do me one small favor. Hit the like button so this video reaches more people who would appreciate it. Subscribe, because we are going to keep tracking every confirmed development on this story as the data rolls in. And share this video with someone who needs to hear about this instead of the wild theories floating around online. Because the actual truth here is honestly more incredible than the rumors ever were. To wrap this up simply, in the summer of 2025, a fast-moving object was spotted heading through our solar system. Within days, scientists confirmed it was not from around here at all. It was the third confirmed interstellar object in recorded history. And it turned out to be one of the most extreme ones ever measured, moving on the sharpest, most hyperbolic path scientists had ever tracked. Estimates suggest this ancient comet could be between 3 and 12 billion years old, meaning it is entirely possible it formed before our own sun even existed. As it swept past the sun in late October of 2025, it heated up and became active, releasing gas and dust that our most advanced telescopes were finally able to study. The James Webb Space Telescope captured detailed chemical readings, showing a coma dominated by carbon dioxide, unusually high levels of heavy hydrogen called deuterium, traces of carbon monoxide and water, and a chemical fingerprint that points to a formation environment completely different from our own. Hubble helped pin down its size. SphereX watched it erupt after its closest approach. And dedicated searches for artificial signals came back completely clear, confirming this is exactly what it appears to be. A genuine, natural ancient piece of another solar system, passing quietly through our own before heading back out into deep space, likely never to return. That is the real story, backed by real data from real telescopes, gathered by real scientists working together across the globe to make sense of one extraordinary visitor. And it is stories like this one, grounded entirely in verified science, that this channel exists to bring you first. So if you have not already, follow now. Drop a comment telling me what part of this surprised you the most, and share this with someone who would find it as fascinating as you clearly do. Because the universe is full of ancient travelers. And thanks to telescopes like Webb, we are finally starting to meet them. We will see you in the next one.